All right, let's look at 4 electron pairs. So this pair, right, I would like you to put a asterisk to it and highlight this shape. Okay, this is very important shape. In fact, this is the only shape I need you guys to memorize the shape and the bond angle. Okay, for the whole VSEPR, this is the most important shape. You aren't going to be able to deduce this shape, all right, by thinking about it, because it is in 3 dimension. Okay, so for 4 bond pairs, right, you will form this shape. Is called tetrahedral. Okay, look at this shape, how beautiful it is. Tetrahedral. This is a tetrahedral shape. Okay, all the bond angles all around this molecule is 109.5. 109.5 from bond pair to bond pair. It's all 109.5. Alright, let me show you how to draw it. Okay, so for a 3-dimensional shape, right, we're gonna start adding in the wedges. What do the wedges mean, right? The wedges basically means solid wedge means that the bond is coming out of paper. Okay, coming out of the paper, and dash wedge, right, is going into the paper. Okay, dash wedge is going into the paper. Okay, so this is just to convey the 3-dimensional shape of this tetrahedral shape. All right, so let's look at the 2 advanced shapes. So you have 3 bond pair and 1 lone pair. No matter where you put a lone pair, it doesn't really matter. So it will look something like this. Okay, can you see? This being the lone pair on top, and then the 3 below. Okay, this shape, right, we call it trigonal pyramidal. Trigonal pyramidal. Okay, it's like a pyramid below. Okay, with a trigonal base. This shape is trigonal pyramidal. Okay, then the bond angles here, right, are slightly compressed because of the lone pair on top. Okay, so remember, lone pair bond pair repulsion is greater than bond pair repulsion at the bottom. Okay, so all this shape, right, will compress from 109.5. You will minus 2.5 degrees. Okay, remember this, minus 2.5, so the bond angle will be 107. Okay, so do this, minus 2.5 degrees. Okay, minus 2.5. So this shape is trigonal pyramidal. Right, last but not least, what happens if you have 2 lone pair and 2 bond pair? So this is like the shape for the very famous water molecule. So you have here another bond pair converted to a lone pair. So you will get this shape with two lone pair. 2 lone pair on top and 2 bond pair below. Right? This shape you can see is just a bent shape. Bent shape. Right? So for this bent shape, your angle will be a further 2.5 degrees smaller. Okay? Because of the 2 lone pair exerting this repulsion towards the 2 bond pair. Right? So it will be another 2.5 degrees smaller. So the bond angle is 104.5. Some schools will put 105. That is okay. So because the bond angle for water molecule is indeed 105. So anything from 104.5 to 105 is both acceptable.